Number 5 says the monthly utility bills in a household in New Paris are normally distributed with a mean, better off using that one, $250. And the standard deviation.
You're right.
Utility bills randomly selected. Answer the following questions. Part A. Find the probability utility bill is less than $250. So we want the probability that our X that we select is less than $250. Don't get confused on these, because that last section that we did, we had to use the continuity correction. You don't have to do that on everything. You only do that when you're changing a binomial, trying to change it into a normal setup. This problem, we don't have to use that continuity correction where we got to change it to like 249.5 or any of that. That's only when you're doing something, and we'll get to a couple of problems like that on down the road here. But this one, these are the ones that we did early in the chapter, and you just have to look at that, and all we're doing is we're looking at, this is normally distributed. Our mean is 250. 35 is the standard deviation, so we would add 35, another 35, another 35. What's that? 320 there. This would be 355, 285, so on, so on. We could do it on the other side. This time we're trying to find out that we pick a bill at random and it's less than 250. So we're right there. We want it to be less than 250. That's that area. We should be able to do this without actually getting our calculators out. What do you know about 250? It's the mean. What part of the area is below the mean? 0.5, 50%. So 0.5 would be our probability, or the area, whichever one. They said probability this time. Does it matter if it says probability or area? It means the same thing. If you wanted to know how to put it in the calculator, I'm going to write this up here. For the calculator, since we have raw scores and we really don't want to change those raw scores into a z-score every time, even though you'll notice on down through here, somewhere I think on here, maybe it was on the first ones that we did, thought there was some on here where we wanted to change raw scores into z-scores, maybe not. But so that we don't have to change it on our calculators, we put in the low limit. Come on, pen. Do it well. High limit. What else do we put in? Mean, standard deviation. We hit second bars, normal CDF, sorry I had to think. Normal CDF. Remember, CDF is if we want from some point a direction, we want the cumulative, all of it added up. If we just wanted the 250, then we would use PDF instead of CDF. So on the calculator on this one, what would we put in? Negative 10,000. And again, does it have to be negative 10,000? You could probably use negative 1 on this one, because how many people are going to have a bill that's negative 1? Nobody. All right? We just use negative 10,000, and sometimes negative 10,000 will work. There was a couple of problems on a couple of the assignments where the numbers were like 625,000. Well, then negative 10,000 won't work because we're dealing with bigger numbers. What's our high limit? Our mean? Standard deviation? Anybody punch that in their calculator? You get 0.5? Actually, I think the calculator says something like this, doesn't it?
And then it has a 5 in the end.
Has a 5 out here on the very end. Not sure why. Part B. Probably got that 5 now that I think about it. It's probably got that 5 on the end. Because it's actually including the 250, what's exactly at 250. Part B says, find the probability that the utility bill is between, so we want probability that the bill is between $175 and $225. So 175 to 225. What would we put in the calculator this time? Normal CDF. Go ahead.
175, 225, 250, and 35.
Some of them on the test, I'm going to ask you draw this. Some of them it won't. I like to draw it every time, just so I have some idea. This is 250. That's our mean. We're going from 175 to 225. 175 to 225 might be somewhere from like here to here. I like to do it just so I know about what my probability or what my area should be there. I'm looking at that and I'm thinking, maybe 30%. All right? I know it's not 50%, right? Because that would be way too much. And I know it's probably not less than 5% because that's too little. Punch all this into your calculator, what do you get?
0.2214.
2214. Does that seem feasible? Seem like that could be a normal answer? Yeah, for that 22% of the bills are between 175 and 225. Part C, find the probability that the utility bill is more than 275. So probability at X is greater than 275. So if I drew this out here, 250 is here. The first standard deviation we said up here was 285. 275 would be somewhere about in there. We want that probability. So it's almost like we're getting rid of from one standard deviation down. Well, we know that for one standard deviation there is 32%. This down here would be 50%. That area that we don't want, it looks like about 82%. So I'm guessing that our answer over here should be somewhere around 18%, probably a little more than that actually. All right, just guess. What would I put into my calculator? What's my low limit? 275. High limit? 10,000. Mean? 250. 35. Punch all that into your calculator. Say it again. 0.20375.
2375.
About 23-24%. So if you live in New Paris, what's the probability that your bill is going to be more than about $275 a month?
24.
About a quarter of the time, 24%. So if we went to New Paris and we picked 4 people, how many of those people are going to tell us that their bill was $280?
1.
Probably 1 out of the 4. That'd be my house. So I get to hear from my wife every month. Our bill this month was $320. Nobody ever shuts off lights. I just keep my mouth shut and go on, because you walk into my house, Jake, front door's always wide open, isn't it? And I'm like, shut the daggone door!
That's what it is.
I like looking out the door.
What? You don't got windows?
I got the blinds on.
You have blinds, so she's not.
Pull them up for a little bit.
That would be all right with me, but I've learned to just keep my mouth shut.
Kick it outside.
I just go outside and go to the barn.
Go to the bar.
You should move into the barn.
I will, that sounds like.
I will.
I gotta get it ready.
About 10.
At 500 utility bills, so we're picking 500 bills at random. You got 500 utility bills. How many of them would you expect to be less than $220? So we want X to be less than $220. What would we put in the calculator to find this probability, first of all? What's our low limit?
220?
Negative 10,000. Make sure you don't make that mistake. Make sure you think about it, all right? I want from 220 down, so got to have that low limit. Then 220 is the high limit. Then what? Mean, which is 250, 35. What's that give us? 1956. Now that's not our answer this time. That's our probability. Our answer is how many of the bills out of this are going to be less than 220. So we take that number, times it by 500. Come on, don't do this to me. No! I was going to have that crap on there. What did it come out to be? 97.8. So are we going to leave our answer 97.8?
No.
We're going to say about what?
98.
About 98 bills. About 98 of the bills will be less than $220. So about a fifth. About 1/5 of all bills are less than 220.
Yeah, last team.
Is it like not that hard of a game because
I mean, it's hard.
Number 6.
oh wow, get over it.
Two.
And they're like more, and like get the whole thing.
Problem number 6, these are the ones I was talking about that I couldn't find. I don't know how I could find their next problem. Says find the corresponding z-score. So for part A, we got 0.00017. We want to find the z-score that's not equal to. We want to find the z-score that corresponds to. On these, or on this one, not on all these, where you find the z-score, but on this one, what you're going to use, you're going backwards. So instead of us knowing the scores down here along the horizontal axis, this time we know that we want the area to the left to be that little number, which is probably going to be somewhere way out in here. So it's going to be some real small thing. That's the z-score we're looking for. Somebody give me a guess what z-score is going to be way out this way. Remember, what's this on the z chart?
0.
Yeah.
-3.
-3 something probably, -3 point something. It's going to be a real small one, right? So what we do on our calculator, we punch into inverse norm. That's telling the calculator, if we don't know the score this time, we want to find out the score. So you punch in inverse norm, and then all you punch in is the area. So inverse norm, because we're going backwards, that's what inverse tells us. And we punch in the area. What's it give us?
Negative 3.58. Negative 3.1.
Negative 3.1?
That's
Negative
a big
3.58,
one.
sir.
No, I'm saying what you did.
Oh, I had to do it with stupid pen. Does that make sense?
Yes, sir.
Yeah, it makes logical sense there. Part B. Somebody read that to me. 50th percentile. 50th percentile. We could punch this one in the calculator. We know that the 50th percentile, what's the area going to be? 0.50 or 0.5. We could punch it in the calculator same way, inverse, norm, and what's our area? 0.5. Probably really shouldn't have to, because what's the z-score that has 50% of the data to the left of it? 0. Is that what it came out to be? Part C, 47.21% of the distribution is to the left. So we're looking at this curve, we want 47%, remember on our standard normal chart, our Z chart, 0, we want 47% to be to the left. Somebody give me a guess, where should we be about at? Should we be in the positives or negatives?
Negative.
We should be in the negative, so our answer, our z-score should be a negative something. All you're going to do is you're going to punch in what on your calculator? We're going to change that 47.21% to
Negative.
0.4721. And then again, you punch in inverse norm, 0.4721, should tell you the answer.
Negative 0.065.
0.069. Does it make sense? Your battery's dead. I'll give you some here in a second. Take my calculators out. I'm gonna try to do D over here so I don't have to erase it yet. 88.1% to the right. Here you gotta be careful on this one. This time we're looking at to the right, so we want 88%. That's 0, 88% to the right is gonna be that. Can we just punch in that 88% in our calculator and it's gonna tell us? No, because it's gonna tell us the score where it's 88% to the left. So what do we need to do? We take 1 minus, change that to a decimal, 0.881. What's that give us?
0.119.
That's this area here. Now, we really don't care about that area. What we do care about is that z-score right there, and that's going to tell us that z-score if we use inverse norm and punch that number into the calculator. What z-score does it give you? Negative 1.18. Anybody else get that? So that's letter D there. Again, those are z-scores. A lot of the times this chapter we figured out how to use the raw scores and we never bothered with changing everything to a z-score. But sometimes you may have to change it to a z-score for whatever reason. Number 7. Oh, I'm sorry, there's an E. 70.54%. A little harder on this one. Terrible. Got 0 there in the middle. We want 70.54%. So we want 70% of the data to be between. Well, again, no way on the calculator to do that. How could we do it? If this is we'll change that to, that area is 0.7054, right? How could we figure out this score and this Z-score? What do we know about these two Z-scores, first of all? They're the same, just opposites of each other. So how could we probably, then if they're going to be the same and just the opposites, we probably just want to find this one and do the positive, right? So how could I find that Z-score? So 1 minus 0.7054, what's that give us? 2946. Now is that what we punch in our calculator? Is that this area right here? You got to divide it by 2 because it's on each end. So we got to divide that by 2. What's that give us? 1473. That's the number that we put in. We hit inverse, norm, punch in that number. That number, that 1473, that's the area right there. That's going to tell us this Z-score. So what's our Z-scores? What's this? What's the one the calculator gives you? I'm guessing it should be a negative, right? -1.04. What's the other one? Positive 1.04. So those two Z-scores, in between those two Z-scores, is about 71% of the data. Or probability of picking something in between those two Z-scores about 70% of the time. Number 7, the time spent in days waiting for a heart transplant for people ages 35 to 49 in recent years can be approximated by a normal distribution, where the mean is 289 days and the standard deviation is 17.8 days. So mean 289, standard deviation 17.8. So if you're waiting on a heart transplant, average waiting time 289 days with a standard deviation plus or minus 17.8. What's the what waiting time represents the 20th percentile? So the 20th percentile looks like that. What can I change that into as far as the area goes? 0.20. And what that's saying is, we're on this normal thing here. We got, if we're using our Z-scores, that's 0. We're not really going to use our Z-scores this time, but we're going to actually put that 289 right there. We want the 20th percentile. We want 20% of the people to wait less time than us. So that would probably be somewhere about in there maybe. What kind of Z-score should we get there? All right, yeah, what kind of score should we get there? Should it be more or less than 289? Should be less than 289. That's what we're looking for, right? We'd like, if we got to have a heart transplant, we'd like to wait less than 289 days because we're most definitely more important than anybody else on this list waiting for a heart transplant, right? So that's what we're looking at. This time we're going to use our raw scores instead of the Z-scores. You're still going to use the inverse norm because we're looking for the score. We're actually looking for the number of days this time. But we can't just punch in the area. We're still going to punch in the area, but we don't want to just punch in the area because we don't want a Z-score. A Z-score doesn't tell us anything. We want to know how many days are we going to have to wait. All right? So what else does anybody remember what else do we have to punch in? Same idea as all the other stuff.
U
And
standard deviation.
so punch that into your calculator. Will I get Malachi some batteries here?
SD. ES. LSD. You're a good man.
What'd you get? 274.01. So what's that telling us? Oops, 274.
He'll be dead by then.
So if we're waiting in that group, and we're in that 20th percentile, we'll end up waiting about 274 days.
For a heart.
Part B. What waiting time represents the second quartile? Got to think back to earlier this year. Does anybody remember second quartile? What's that mean? It's right in the middle, right? That's 50%, right? You got first quartile, 25%, second quartile, 50%. What's the third quartile? 75%. So same idea, we're going to punch in inverse norm. What's our area going to be this time? 0.5, 0. What else are we going to put in? 289. And then 17.8. We probably don't even really need to put this in the calculator. How many days are we going to be waiting? It should be 289 if we're right at 50. Punch it in your calculator and see if that's what it gives you. So give you 289. Yes, no, maybe?
Yeah, it does.
Number 8. Two a I'm not gonna have to fire him here pretty soon. He's just gonna quit because he's gonna hate me so much. See that look?
Smile, it's Friday. Well, he said you're not wrong.
Everybody got that? Yes, no, maybe?
Maybe. Hey, you gave that offer.
Number 8. I know, but Malachi, you're one of them that ought to be wanting to hurry so that we can get back to the 1 through 4. It says, given a population has a mean of 225, so our mean this time is 225. Standard deviation of 40. Sigma is 40. Find the mean and standard deviation of the sample means. Remember, mean of the sample means looks like that. It's mu with the subscript x bar. And the standard deviation, which that shouldn't say standard deviation. Does anybody remember what that's supposed to be called?
Standard error.
Should be the standard error. I'm just not intelligent enough to keep track of that. This time they tell us that for A, they tell us that n is 100. So for A, n equals, not 100, 500. 500, right? 500 for A. How are we going to find the mean? Does anybody remember the formula to find the mean?
Isn't it the same?
Same thing. So what's this answer? 225. Same. Those two are always the same. The mean of the sample means and the mean of the population, always the same. Anybody remember the formula? There's actually a formula to find the standard error.
Standard deviation divided by the square root of n.
So this standard error goes by how much of a sample we have, how big of a sample we're taking. So in this case, what's going to go on top? 40, what goes on bottom? Square root of 500. Somebody figure that out and I'll explain to you again what we're doing. We're going to have, this is our 1.788.
Sir.
So 1.79 maybe, somewhere around there. What we're doing here is we're taking the original, the mean was at 225. It looks like that, and our standard deviation is about 40. So we go 265, 305, 345. We go out, most everything should fall within 3 standard deviations above or below, right?
We don't have to graph it, do we?
Not on this one, but so, because I want you to understand what you're actually doing here. So what we're saying there, that's our, if we had the whole population, now what we're doing is we're saying, okay, the mean is still 225, but now we're only going up by about 1.79, so about 2, let's say. So now we're going to have something that looks like this. This is 227, 229, 231. I know you can't hardly read my numbers there. But what's happening is, now we've done what to the data?
Smush it.
We've squeezed it all together. And we're saying every time we pick a sample, the mean of those samples, we don't know what each number in the sample is going to be, but the mean of those samples should fall in that smaller area. Because we can't always have the whole population. Part B says N is 1,000. What's the mean of the sample means going to be? 225 still. Standard error,
40 divided by 1,000.
40 divided by
Third,
square root of 1,000,
1.264.
1.264. Anybody else get that? So those are your 2 answers there. Everybody got that one? Number 9. This time we got N is 64, so we're picking a sample of 64 people or whatever it is that we're doing. Find the probability that the sample mean is less than 24.3. So our sample mean is, we don't want that. Our regular mean is 24, and our standard deviation of the population is 1.25. We're trying to find the probability that the X bar, the sample mean, is less than 24.3. This time, notice, we're not finding X is less than, we're finding X bar, because we're taking the sample, not the whole population. On all the other stuff that we were doing previous to this number here was X, or this variable here was X, because we were just looking for that certain value. Now we're taking the means of all those. We're going to do the same thing. What do we punch in? What are you going to use on your calculator?
Inverse
Normal, square.
Normal, CDF, what things do we put in?
-10,000.
Okay, we put in the low limit, high limit, mean, and what? Standard deviation. And actually, we put in the mean of the samples and the standard deviation of the samples. Now, the bad thing is, do we know the mean of the samples and the standard deviation of the samples?
Wait, so is the X bar supposed to be on
So we need to find those, don't we? How do we find the mean of the samples? So first, you might want to write that down. First, you got to find mean of the samples, and then you got to find the standard error also. What's the mean of the samples going to be? 24. It's the same. So that's pretty easy. Standard error of the samples, how do we find that again?
The 1.25
1.25.
divided by square root of 64. Point 156.
1.5 what?
6.
6. Now, be careful. We want from 24 down, so what's our low limit? Negative 10,000 or something like that. What's our high limit? 24.3. What's our mean for the sample means? 24. What's the standard error for the sample means? 0.156. Punch all that into your calculator. But stop. What's our mean? 24. We want everything lower than 24.3. Should we be more or less than 50%?
More.
If we're looking at this, and 24 is right here, 24.3 is going to be somewhere here, right? And we want everything less than that. Should we be a little more than 50%? So try it and see. Is it a lot more? Is it a lot more? Why is it a lot more? Jacob's saying it's a lot more.
0.97?
Because what's our standard error here? 0.1. So when we go up, when we're here, when we're looking at this, it's almost straight up and down, and 24 is right here. How much do we go up by to get one standard error away, or one standard deviation away? You just go up by 0.1, so that'd be 21.15, then about 23, then or
23.15.
so on, 24.15, 24.3 would be right here. That'd be the second one. So we're at 2 standard deviations and below. That's a whole bunch, and that's what causes it to, it squeezes it all together. So what'd you come up with?
97.
0.97? Everybody agree with that? So about 97% of the data would be at 24.3 or below.
See, it's a good day.
Number 10, a survey of U.S. adults ages 18 to 29 found that 93% use the internet. You randomly select 100 adults 18 to 29 and ask them if they use the internet. Part A, probably should write this up here. What's our probability this time? 93%, so 0.93. What's our N this time? 100, that's how many we're picking. Another thing that we could find is our Q. Anybody know what our Q is? 0.07, subtract that from 1. We need all 3 of those when we're doing something like this. When it's a binomial set up like this. Find the probability exactly 90 people say they use the internet. So we're trying to find the probability that our X bar is equal to 90. We want exactly 90. Remember with this stuff, when we're doing the binomials, we're finding if 93 is right in the middle, we're finding the area of that certain bar. All right? That's if you're using the binomial. If we have to switch it, which we're going to do on the next, or we're going to actually do here in a second, if we're trying to switch it to make it normal, so we can just use our calculator and use the normal CDF, then we have to do that. What was it called again? I said it earlier. The correlation thing, or whatever it was called. Can't remember the word now. Does anybody remember what do we have to change this to if we want exactly 90? If we're at 90 right here, let's say 90 is right there. I know it's not, but if 90 was right there, we're just trying to find the area of that bar, so we're trying to find this area. What do we go down to? Remember, how much do we go down each time? Go up or down? Up or down by how much? 0.5. Go up or down by a half. So what would we change that to if we're going down by a half?
89.5.
89.5. Go up, what would we change it to? 90.5. So that way, we're not just seeing that part right there. We're actually getting that whole area that we want. And when we change it that way, what we can now do is now we can use the normal CDF. Instead of having to do all the other stuff. What do we need? What things do we need to punch in for the normal CDF? Low limit, high limit, mean, standard deviation. So we need those 4 things. Do we have all those things? We got the low limit. We got the high limit. Do we have the mean?
90.
If it's a binomial, do we have the mean? Do we have the standard deviation? No, we got to find it. Does anybody remember with the binomial, how do you find the mean and standard deviation? N times P is the mean. What's the standard deviation?
Square root of n times p times
That's why we found those 3 things at the beginning.
93.
So what would our mean this time? What's our N? 100 times, what's our probability? 0.93. Thank you. She just wanted to come up here to see Malachi's lovely face.
That's good, Jonah heard.
What's that give us?
Who's he here?
What's 100 times 0.93? Let's go so we can get this done. 93. So that's our mean, 93. Our standard deviation, square root of 100 times 0.93 times 0.07.
2.55.
2.55. Got to make sure that you're finding that when it's one of these where you're trying to make it normal, but it started off being a binomial where you were asking like a yes or no question. Remember, a binomial is something that's just got two possible outcomes. We're trying to make it normal so that we don't have to mess with all that binomial stuff. Because the binomial stuff's where you had to go, okay, if I want this, then I got, if I wanted, what's the probability of this? And 98, well, 98 or less, well then I got to find this probability, that probability, that probability, that probability, that one, and that one. And what do I do with all those probabilities down to 0? Add them all up. Do you really want to start at like 90 and go down to 0 and add them all up? Probably not. All right, so this allows us to make it normal, say, it approximates that normal curve. It gets close enough for our, what we're going to use it for. So this time, what would you punch in? What's our low limit? 89.5. What's our high limit? 90.5. What's our mean? 93. What's our standard deviation? 2.55. You punch all that in. 0.0784. So about 8%. So it makes sense that about 8% of the data is going to be right at 90? Yeah, probably. Does anybody remember? I'm not sure about this. On the binomial. Let's try the binomial. Does anybody remember on your calculator, if you go to binomial PDF, anybody remember what all we had to put in for the binomials? If we were trying to find the area of 90, if we were just going to leave it as a binomial instead of trying to change it to normal. Nobody remembers any of that? Oh my gosh, I'm such a great teacher. Nobody remembers what we did last chapter, chapter.
That was like last year. He thought it was funny, he's not gonna laugh.
Somebody punch in binomial. Let's try it. Let's see. If we just put in binomial,
Where do you turn to that?
still on second bars, right?
Yeah.
And it's down.
Oh, dang, that's.
Let's go binomial PDF, because all we want this time is 90. Binomial PDF, that's just going to tell us the one score. Let's put in, I think it was one that you want the score. The mean and the standard deviation, is that right? What score do we want this time?
0.78?
90.
90.
What's our standard, or what's our mean? 93. And standard deviation was 2.55.
It's domain error.
Says domain error.
The binomial PDF was N, P, and X.
So we need N, don't we? So let's do, so I was wrong. So it's N, P, and then X. What's N this
What
time?
PDF did you
PDF.
Was 100.
N was 100, so let's try that. Punch in 100. Our P was 93.
0.07.
And our X was 90. Remember, we're just looking for that one bar at 90. What's it come out to be? It's come out pretty close to that. So we could have used either one.
0.07.
Is it 0.93?
I don't know, did you have to put in .93?
Yes.
Same thing.
Then 100, 0.93, and then 99.
I got a domain error.
When you put in .9 or 93, you got a domain error. Yeah, I guess .93 is our probability. I don't know, I just forgot my point down. So again, we could do it that way, but if the next problem, I'm not sure what the next problem says, but if the next problem says 90 or less, do we really want to punch this in 90, 89, 88, 87, 86, 85, 84, so on, so on, so on.
83.
We don't really want to go through all that, right? So that's why we're changing it into the normal so that it makes it a little easier. The bad thing with the normal, change it to normal, you got to remember to compensate for not being right at 90. You want to go from here to here. Part B.
Look at Mark Report.
Do what? Part B, find the probability that at least 90 people say they use the internet. So this time it's at least 90. So this time we would have to do 90, 91, 92, 93, 94, 95, all the way up to 100. We don't want to do all those. So we're going to probability that in our sample we get at least 90. So are we including 90?
Yes.
Yeah. So when we go to compensate for the mess up here, because we're using normal instead of binomial, what we need to do is we need to change that to what? Do we want to go up to 90.5?
Yes.
Is that what it's gonna, is that gonna include 90 if we go up to 90.5?
Well,
No, we want to go down, right? So we want to go greater than 89.5. Since we wanted everything above, we're looking on this chart. 93 is right in the middle. 90 is right here. We want to include 90, so we want to start down here so that we make sure we get that whole 90 bar. What's that telling us then? We're going to punch in on our calculator. Normal, CDF,
89.5.
is that our low limit?
Oh, it is not. Yeah, it is.
Yeah, it is. 89.5. What are we going, what's our high limit? 10,000. What else do we need to punch in?
The mean.
Mean and standard deviation. Ah, crap, we didn't find those, did we?
No, we did not.
I think we did on the last slide, didn't we?
Yeah. It
What was the mean? 93. What was standard deviation? 2.55. Punch all that in. Before you do that, if 93 is our mean, and we're down here at 90 saying everything above 90, what kind of probability should you get, or what kind of error should you get? Should be a lot, shouldn't it? It's going to be more than 50% for sure. What'd you come up with?
91.
0.91?
Yep. Or 92, I guess.
What's 91 what?
5.
5? Does everybody agree with that? Part C, probability that fewer than 90 people say they use the internet. Fewer than 90 people.
so now we use 90.
So now we want
Less.
less than 90. Now be careful again. We want less than 90, so are we including 90?
No.
So if we go up to 90.5, that would be including 90, wouldn't it?
89.5.
We go to 89, so we change this to less than 89.5. Now, there's two different ways you could do this if you're using your brain a little bit. We just said greater than 89.5 was this. How could we find the stuff less than 89.5?
Minus negative.
You could just take 1 minus 0.915. You could do it that way. Somebody do it that way. The other way we could do it is by punching the stuff in the calculator. What are we going to punch in?
Negative 10,000.
Negative 10,000,
89.5.
89.5,
93.
93,
2.55.
2.55. Anybody do this one yet?
Yeah.
What'd you get?
0.085.
0.85. Anybody punch this one into your calculator yet? pretty close.
Will you take either?
Either one.
Well, actually, round up.
It rounds up to 85.
Yeah. So it went down.
Number one, just going real quick. What is half the area under a normal curve? 0.5, 4, 50%. I'd accept either one of those. Number two, draw two normal curves that have the same mean but different standard deviations. If I draw my first one, and that's supposed to be my norm, the one that we use all the time, what could I make the next one look like?
Very impact.
Less spread out, maybe put some number in here. 10 is our mean. They have the same means. So if we're looking at similarity, their means are the same. And what else? Give me another thing that's the same about them.
They're normal.
They're both normal. So for similarities, they have the same means and they're both normal. For differences, different standard deviation, and give me something else. How they look different.
With.
One is more.
One's more straight up down, one's more spread out, however you want to say it. Number three, find the indicated area under the standard normal curve by using the standard normal table. I don't care if you use your table or if you use your calculator. We want to the left of a z-score of 125. So if I was looking at this on a graph, 1.25. 1.25 might be somewhere about in here. We want the area to the left. So we're looking for that area. Is that area more or less than 50%?
More.
More. Should be. So when we come up with an answer, it should be more. If we use our calculators, on your calculator, all you got to punch in, what did we say last time? What do you got to punch in?
-10,000 and
Negative 10,000. And we're on the Z chart, not the raw scores. So we just punch in the Z score here, 1.25. We just punch in the low limit and the high limit. The only time we need the mean and standard deviation is when we're using raw scores, not Z scores. 0.89, anybody else get that? I got 0.894, is that right?
Yeah.
That was part A.
How many places do you want to pick up?
Usually 3 probably, 3 or 4. To the left of negative 0.5. So what are we going to punch in the calculator this time? Negative 10,000 again, because we're still looking at stuff to the left. Negative 0.5. 0.308. Anybody else get that?
And what do we plug this into? CDF.
Normal CDF. Normal, or no, does it say normal or just norm? Norm. Does it have an AL on it?
Oh, yeah.
Normal CDF. So you go second vars, normal CDF, punch those two in. Letter C is a little different because now we're looking at stuff to the right. So negative 2.8, we want all the stuff to the right. What are you going to have to do there?
Put the number first.
All right, so negative 2.8, that's your low limit. What's your high limit? 10,000, so just tell the calculator, hey, we're looking at the other side of the graph this time.
7?
997. Everybody agree with that? D, same idea. 3.1. think about this before you do it. If we're at 3.1 standard deviations, how much of the area is gonna be to the right of that?
All of it. Or net, none of it.
Somebody help out, somebody help out Malachi, make sure he knows his right
All
from,
of it.
right from his left. Hardly any of it.
That's what I said.
Very unusual, you said all of it.
I did.
What goes in here?
3.1.
3.1, high limit, 10,000.
I got.
Then you got 9.6, a bunch of numbers, E and -4.
Okay, so.
So 9,
I was tripping.
9.67, a
9.67,
bunch of numbers, and then E, -4.
E -4. What's that tell us?
Nine.
You gotta move the decimal
Nine
four
times
places.
50.
You move the decimal how many places?
Four to-
There it goes. So how many zeros? So it's gonna be 0.00097, or 967?
Yeah.
Is that a very small amount?
Very.
Yeah. It's like a, not even 1/10 of a percent.
Very good. Very good.
Didn't erase everything.
What?
Letter E. This time we want to be in between these two numbers.
Oh, that's easy.
Still easy. What do you put in for your low limit?
Negative 1.8.
1.28. What's your high limit? 1.28.
1.799.
0.799. Anybody else agree with that?
This one's stupid.
Letter F. That. Letter F. This time they want the area out this way, area out that way from negative 1.96 and positive 1.96. How could we find that? Can't punch it in the calculator that way.
You can find both of them though.
You could find both of them and add them together, or you could find both one of them and do what?
It's the same. One goes one.
Multiply by 2.
It's the same.
So what do we punch in if we just want to find this area over here?
Negative 10,000.
Negative 10,000,
Then negative 1.96.
negative 1.96. What's that give us?
0.024.
024
And then times 2 would be 0.049.
times that by 2, 0.049. Tell me something about that event.
Crazy.
If it's 0.049, tell me something about it.
It's half of it.
Very unlikely.
It's unlikely, right? If it's less than 5%, it's unlikely. Number 4, last one real quick. Same idea on this one. Says find the probability that Z is less than, so you're still on your Z chart, Z is less than 1.29. You're still going to do the same thing. You want all the stuff less than 1.29, so what's your low limit?
Negative 10,000.
Negative 10,000. What's your high limit?
1.9.
1.29. Somebody punch that in real quick.
0.901.
0.901. I got 1.5. Is that right? That's A.
4 places.
B. What do we punch in this time? Let's just put what we punch in the calculator.
1.785.
1.785, that's our low limit.
10,000.
10,000 is our high limit.
Oh, it's 100,000. 0.037.
C. How are we gonna punch that one in?
Negative 105.
2.
105.
So we're looking for the stuff in between those two numbers.
It's 0.706.
Everybody agree with that one? More of that. D. What are we gonna have to do on this one?
Yeah, add them together, maybe, no,
So we can't, how do we punch it in?
-10,000.
Negative 10,000, negative 2.9, punch that one in. What's that give us? 0018, is that right?
Yep,
And what do we do with that?
times it,
Times it by 2, what's that give us?
370. Yeah,
Test on Tuesday.
it was 1,865